Right, so you should have this note page sitting in front of you. What we're going to do for this section is we're going to look at isosceles and equilateral triangles a little bit more closely than we did when we first just introduced them. So first of all, we're going to do the isosceles triangle. The parts of an isosceles triangle. So we have the two congruent sides are called legs. So you can label this side leg and that side a leg, and we're going to mark it with our congruence mark, just one mark there. The angles where the sides intersect is called the vertex angle. So up here, this is going to be our vertex angle. Then the opposite side of the vertex angle is going to be the base. So this is the opposite side of that angle, and we're going to label this base. And then the angles along the base are called the base angles. So these two right here are base angles. Okay, and again, we're probably going to have to pause the video as we go through the notes. So just pause it until everyone gets that written down, and then you can move on. All right, so those are the parts of the isosceles triangle. The theorem for this basically says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So I have my two sides are congruent, then that means the angles opposite those sides are congruent. So for example, if AB is equal to BC, then I can say that the measure of angle A is equal to the measure of angle C. Okay, then we have the converse of the isosceles triangle theorem. So we know if this is if P, then Q, then our converse is going to be if Q, then P. So here, if two angles of a triangle are congruent, now we're starting with these two angles are congruent, then the sides opposite those angles are congruent. So then I know that these two sides are congruent. So for example, if the measure of angle A is equal to the measure of angle C, then AB is equal to BC. Okay, so let's practice with the information a little bit. Here I have an isosceles triangle. These two sides are congruent, and then I know because of that that these two angles are also congruent. So this would tell me that the measure of angle J is going to be 68 degrees. And then I also know that the measure of angle K, that has to be 44 degrees. And I'm getting that by taking 180 minus 68 minus that 68, and that gives me 44 degrees, because those angles have to add up to 180. Okay, over here on this side, here they tell me that the two sides are congruent, so I know it's isosceles, but then they just tell me this angle is 106. So for this one, to figure out what these two angles are going to be, I know that they have to add up to 180 minus 106, right? So that's going to be 74. So I know 106 plus 74, and those two need to add up to 74, would give me 180 degrees in this whole triangle. So if I figure out that these two in total need to be 74, and then I just divide it by 2, that gives me each angle is 37 degrees. Okay, I would like for you to go ahead and do number 3 on your own, pause the video, and then when everyone's done, come back and check. Okay, this is what you should have gotten for number 3. You've got the side length, and then you use the same 180 minus 77 would give you that 26 degrees. All right, here we're going to add some algebra back in as we keep doing. So I have an isosceles triangle. These two sides are congruent, which means that these two angles have to be congruent. So what do I do with my expressions? I'm going to set them equal to each other. So when I do that, then I'm set up to just solve for x. So I get 3x minus 30 is equal to 9. And then 3x is equal to 39, and then 39 divided by 3 is going to give me 13. So x is equal to 13. So I'd like for you to go ahead and do number 5. Okay, and there's your answer to number 5. Now we're going to come over here and look at number 6. Now they're telling us that the angles are congruent. So I know this is isosceles, and if the angles are congruent, then my sides must be congruent. So again, I'm going to set this up with my sides equaling each other. Okay. Okay, and then I'm going to subtract 15 from both sides, so I got 8x, that's supposed to be a minus, 8x minus 17 is equal to 7. Add 17 to both sides, I got 8x is equal to 24, and x is equal to 3. Okay, go ahead and do number 7 on your own. Okay, and there's the answer to number 7. Alright, so here we have a word problem. If triangle RST, in triangle RST, if RT is congruent to ST, and then we're told what the measure of angle R is, measure of angle S, and the measure of angle T, find X and the measure of each angle. Alright, so for these I would draw a picture. So I want to start out by drawing a triangle that is RST. So I've got R, S, and T. It says that RT is congruent to ST, so I'm going to mark those as being congruent. And then if I know that those two sides are congruent, then I know that R and angle S are also congruent. Now that I know that, I'm going to look and see, what do they tell me? Measure of angle R is 9x plus 2, and the measure of angle S is 13x minus 18. So I know that I can set these two equal to each other. So I have 9x plus 2 is equal to 13x minus 18. Okay, so that gives me 4x minus 18 is equal to 2, and 4x is equal to 20, so x is equal to 5. And then you're going to take your angle measures and you're going to plug those in. So if x is equal to 5, then when I put 5 in for measure of angle R, 9 times 5 plus 2 gives me 47 degrees. 13 times 5 minus 18 will give me 47 degrees. Well, of course, right? I need to make sure those are the same. And then the measure of angle T is going to be 86 degrees. Right, I would like for you to do numbers 9 and 10 on your own, and take your time to make sure that you get these done correctly, and then I'll put the answer up. Okay, so here are the answers for 9 and 10. Go ahead and pause that so that everyone has a chance to check. Alright, so that was isosceles triangles. Now we're going to look at equilateral triangles. So if a triangle is equilateral if and only if it is equiangular. So this is called a biconditional statement, right? We can go both ways with this. We can say that if a triangle is equilateral, then it's equiangular, and if it's equiangular, then it's equilateral. So here, if measure of angle A is equal to measure of angle B, which is equal to measure of angle C, then that's my angle measures. I can say that the sides are also equal. AB is equal to BC, which is equal to AC. Likewise, I can go the other way and say if my sides are equal, AB is equal to BC, which is equal to AC, then my measures, measure of angle A is equal to measure of angle B, which is equal to measure of angle C. And we know that if these all have to be equal, that they're all 60-degree angles. So we look at our first problem here. If this is 60 degrees and that's 60 degrees, then I know that has to be 60 degrees because 180 minus 60 minus 60 is going to give me 60. And so I've got an equilateral triangle, which then means that all my sides are the same too. So that's 9 feet and 9 feet. Over here, they're just telling us that all the sides are congruent. So if they're all congruent, I know all the angles have to be congruent, which then just tells me that all of these are 60 degrees. Okay, for our last one here, again, it states it's equilateral, so I know all my degrees have to be 60 degrees. So to solve for x, I can take 7x minus 3 and set that equal to 60. And so that is going to give me 7x is equal to 63, which is x is equal to 9. And then to solve for y, I already know the fact that all of these are equal. All my sides are equal, so I can take 14y minus 59 is equal to 9y plus 1. And so when I solve for y, I get 5y is equal to 60. If I do 2 steps there, and that y is equal to 12.